So we've looked at vectors kind of disconnected from the coordinate plane, and let's take a look at how we can connect vectors not just on a blank sheet of paper, but considering vectors located on a coordinate plane. We know that we can move a vector around as long as it maintains the same length and same direction. This vector W, I can move anywhere around, again, as long as it's pointing in the same direction, has the same magnitude. Suppose I've got a vector here that does emanate, whose foot is at, his tail is at the origin, and whose head is out here somewhere. I can look at that vector and consider it to consist of two components, a horizontal component and a vertical component. Why? Because if I add u to v, the resultant vector is going to be w. So again, looking at any vector that I've got, I can divide it up into a horizontal and a vertical component such that the horizontal plus the vertical equals the vector. And in doing so, I can look at whatever these lengths are, whatever the horizontal component length and the vertical component length is, keeping track of direction. I can call the vector also, I could call it AB. And our textbook's going to say, for example, they're going to say W here equals AB. And they're going to use, again, they're going to use bold-faced lettering for W. Reminder that we can distinguish a vector by putting a little symbol above it. And that we can call a vector simply by its horizontal and vertical component. And the notation they're going to give, it's going to look like they're calling the coordinates of a point. They're writing down the coordinates of a point, and they will say that in context, you'll be able to figure out whether it's a vector or whether it's the coordinates of a single point. You'll see other textbooks call a vector just to indicate that it's a vector and not a coordinates of a point. They'll use little sideways carets, and they'll call it vector AB is W. So again, what happens if we now have this vector, though, moved away from, not simply at the origin? I can apply the same idea of a horizontal and vertical component and talk about the vector in algebraic or in terms of coordinate plane mode. So suppose I consider vector W here. Tail is down here, and head is up here. And I know that the tail has coordinates of 2, 2, and the head has coordinates of 15, 11. How else could I call that vector? I can look at calling it by its horizontal and vertical components. Here's my horizontal component. Here's my vertical component. How do I get this horizontal component? Well, it simply is going to be the difference between the two x coordinates. So the horizontal component is going to be 15 minus 2, and the vertical component is going to be 11 minus 2, or I could call this vector 13, 9. And again, I'm going to use the notation that allows us to see that it's a vector. Our textbook's going to use notation that makes it look as if it were coordinates of a point. What happens if the vector points the other way? Okay, suppose we've got a vector, as I said, pointing in the other direction. Note that we've got up here, for example, a vector that points to the left, and it's a horizontal vector. So the change going from tail out to head is going to go from 7 to 5. That's a drop of 2. And I want to distinguish that as a vector from the vector that points to the right, let's say, and has a change in 2. So just like we did in the previous example, if I subtract from head to tail, 5 minus 7 is negative 2. There's no change in the vertical, so I could call this vector negative 2, 0. Again, I could slide it down and put it in position so that its tail is at 0, 0. The head would be at the point negative 2, 0, and my magnitude is going to be 2. So how about a vector here, vector t, which again points kind of heading down, down south and west. Suppose I know the coordinates of the tail are 13, -2, and the head is 5, -14. I've got a horizontal change in this direction going from right to left, and that change is 5. If I subtract head to tail, 5 minus 13 is -8. And I've got my vertical change dropping from -2 down to -14. That's -12. And again, if I subtract from head to tail, -14 minus -2 is -12.